Welcome to lesson 4, which starts the same as lesson 3. I'm still going to be doing mirrors, but now I'm going to be doing concave mirrors. We're starting again with the rules. Just like before, you don't have to rewrite this if you wrote it from lesson 3. But we start with a horizontal ray to the mirror, and now it's going to reflect towards the focal point, because we're doing concave mirrors. And ray number 2 is going to go to the center and reflect at the same angle. So just the same as before, except now we have a concave mirror. So concave caves in. So I'm going to make it fuzzy in the background. And then I am going to choose slightly different numbers here. I'm going to do a focal length of 2 centimeters inside the circle, remember. 1, 2, put a dot, and a distance of 3 centimeters. 1, 2, 3. Okay, so what happens to the object? Now, I left concave mirrors for last because concave mirrors have a little trick to them. I'm going to get to that in a second. So we're going to start with the one that goes straight over, horizontal, that's ray number 1, and then through the focal point. And ray number 2 is going to go start at the top, go to the middle, and then reflect at basically the same angle. Okay, now here comes the trick. Lots of people look at this and they go, wait, there's 2 images. It hits here and it hits here. But it doesn't actually hit here. And that's what's very confusing. So let's go back to what's going on. What's going on is you're looking on the inside of a spoon, because that's what you do when you're bored, and you notice all the light reflects off your view, and it goes in every direction, but we're only taking care to look at 2 rays of light, this ray and this ray. They both go at the same time. So at this time, they've both gotten to the position where my fingers are. Start here, they go here. So you don't actually hit each other at the same time. Then they reflect, and this is where they hit. They hit right down here at the same time. It just looks like they cross each other's paths, but they don't do it at the same time. It's only after they both reflected from the surface of the mirror, then they hit each other over here. So the image is actually way over here. It's about 1, 2, 3, 4, 5, 6. Looks about 6 or 7 centimeters from the mirror. Should be 6, and I'll show you that from the equation. So using the equation, we've got 1 over DO equals 1 over F minus 1 over, the distance of the image. That's what we're looking for. This is the object. This is the image. This is what you see, something upside down and bigger. 1 over 3. Apologize for that. So 1/2 minus 1/3 is 3/6 minus 2/6. I'll even write it out. 3/6 minus 2/6 is 1 over 6. So the image should be 6 centimeters. We started it with 3 centimeters, and it went to 6 centimeters. So it's twice as big. Went from here to here, twice as big. Now you notice in the homework, I basically say, is it bigger, smaller, closer, or further? Because when you draw this, it's very hard to see that it's exactly twice as big. Could be 2.2 times as big, could be 1.8 times as big. So it's hard to see. Also, is this a real image or a virtual image? Think about it for a second. The answer is it's real. 3 ways to know it's real. First, you know it's real because the light rays actually hit it. Second, you know it's real because it's in front of the mirror, and if it's in front of the mirror, the light rays actually hit it. Third way you can tell is you only have 1 mirror, and it's upside down. If it's upside down, the stuff that was on top gets reflected at the bottom, stuff that's on bottom gets reflected to the top, and you end up with an upside down image. Look at yourself in the inside of a spoon and you'll see yourself upside down. Okay, well, what happens if you're closer than the focal point? And then something weird happens. So we're going to do another concave mirror. Concave mirror. But this concave mirror, let's make a concave mirror that's not so sharp. Let's make one that's shallow. Let's make one where the focal point is, let's make it 12 centimeters. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dot. So we made a mirror. Notice the focal point is still inside the reflective part of the mirror. But now we're going to put our object inside it. Let's keep this, let's put this at 6 centimeters. 1, 2, 3, 4, 5, 6. There we go. So now we have an object 6 centimeters from inside of the spoon, and the focal point is 12 centimeters. This is like if you put your finger very, very close to the inside of the spoon. So let's draw the two rays. The first ray goes horizontal. You notice this does the same pattern every time. Start at the top of the arrow. Draw a horizontal line. Either reflect it towards the focal point, which is what we're doing here. Oops. Got a little wavy, but wasn't supposed to. Okay, second ray starts at the top, goes right to the middle. Once again, it looks like it hits right here, but does it? No, it doesn't hit right there, because this is how it goes with time. They're not hit at this point at the same time. So it's going to reflect at the same angle, approximately. There we go. This angle is about the same as this angle. So what happens to these two rays? Are they ever going to hit? No. They just keep on going off. So we backtrack. We start with the arrow and we backtrack. And we backtrack with this one. And they hit right about here, which means it creates an image. Maybe I'll make an image in red. This one is not upside down. It is behind the mirror. The real light doesn't hit it. So that means it's virtual. It's also not upside down. Oh, I said that already. Anyway, let's look at the equation and see what happens. If you have 1 over di equals 1 over f minus 1 over do. Notice, this will be 1 over 12 minus 2 over 12. This will be negative 1 over 12. di equals negative 12. Negative for mirrors means it's behind the mirror. I want to make one last comment. Pause for a moment on this. One last comment, and then that's what the equation. The equation is 1 over your distance of your image equals 1 over f minus 1 over do. If this is positive, then there's two options. di could be positive or negative. If f is less than do, but greater than 0, you have a real image. di is greater than 0. Try it out. Try it out with actual numbers, and you'll see if f is less than do, then 1 over f is greater than 1 over do, then you can have a positive number. If f is less than do, if you're closer, then you're going to have a virtual image. If f is negative, you always have a virtual image. If this confuses the heck out of you, ignore what I just said. Okay, that's the end of the lesson. Bye.